Example 2, graph each of the following using the slope-intercept method. So we've got a few graphs to try here. Now this is, to me, the most efficient way of graphing a linear equation. So I use this method the most. So when I'm given a choice, this is the method I would choose. So I'm just going to write some instructions on here. What you would do first, step 1, would be to plot the y-intercept first. And then step 2 would be from the y-intercept. Okay, so we'll say from y-intercept, count your slope. So we're going to say count slope. So I'm going to put rise over run as a reminder there. And so you're going to, from your y-intercept, count the slope to find your second point. And you only need 2 points to graph a straight line. So let's use example A to show this. So we're going to put a scale in here. So we'll just count each unit as 1 here. So the y-intercept, so remember y equals mx plus b. So the y-intercept is the b value. So y-intercept is 3. So I'm going to go 1, 2, 3, and I'm going to put my first point there. Now my slope is m. So remember, slope is m. So in this case, slope's 1/2. So that means that 1/2 is going to be my rise over my run. So if this is my only point I know, my y-intercept, I'm going to count the rise of 1 and the run of 2. So then I'm going to go right 2. I'm going to plot that point, and then I'm going to connect those points. Now, just like other times when we've graphed straight lines, we actually want to make sure we put arrowheads at the end. So that means it continues in both directions. Let's look at B. So again, this is negative 3x minus 1. So you're going to plot your y-intercept first of negative 1. So I'm going to put a scale in here of 1 and 1. So negative 1 is my y-intercept, and my slope is negative 3. So for negative 3, my slope is negative 3. I need to see a run, so I'm going to make that a fraction and put it 1. So my slope is negative 3 down, so 1, 2, 3. And then I always count to the right, 1. I find it easier, again, to put that negative sign, thinking about it as part of the rise and just thinking you're counting either up or down, and then you always count to the right. Okay, so put a line, draw a line through those 2 points. One more time, just to practice this again. Y equals 3 over 2x plus 2. Let's put in our scale. Plot my y-intercept first. I'm plotting the point 2 on the y-axis. That's my y-intercept. Now my slope is 3 over 2. So from here, I'm going to count rise of 3, 1, 2, 3, and a run of 2, 1, 2. Now, I didn't run out of room on that question, but if I ever did run out of the room, for example, this was too high up, I could count in the other direction. Instead of going up and right, I could have counted down 1, 2, 3, 1, 2. In fact, you can see how I could kind of extend that through there. So there are options to continue a graph. Let's look at D. Y equals negative 2/3 x minus 2. So again, I want to put my scale in there. So negative 2 is my y-intercept. So my y-axis, I'm going to plot negative 2. My rise over run is negative 2 over 3. So I'm going to count down 2 and right 3. So again, I like to put the negative sign with the rise part. So I'm thinking I'm always counting down. I'm just going to extend that a little bit more. Okay. Again, if I ever ran out of room, I could count up 2 and left 3. But again, I try not to confuse myself with the negative signs. Okay, y equals 3x. You don't see a b value, but keep in mind then this number would have been plus 0. So your y-intercept is 0. So we're going to plot that. We can put our scale in here too. And then my slope is 3 over 1. So from here, my slope is 1, 2, 3 rise. My run is 1. And I'm going to count and draw in that line.